Graph the linear equation using the intercepts. Y minus 2x equals 0. We'll first find the x-intercept, and we'll do that by letting y equals 0 and solving for x. We have 0 minus 2x is equal to 0. Simplifying, we have negative 2x equals 0. And solving for x, we divide both sides of the equation by negative 2 to get x equals 0. Therefore, the x-intercept is the point 0, 0. We find the y-intercept by letting x equal 0 and solving for y. We have y minus 2 times 0 is equal to 0, which simplifies to y equals 0. So we find that the y-intercept is also the origin, which makes sense because the x-intercept was the origin, which means that the graph crosses both the x and y-axis at that point. So in order to graph, we'll need to find more points than just our intercepts. Let's find two additional points. First, we'll let x equal 1, and we have y minus 2 times 1 equals 0, which is y minus 2 equals 0, and we add 2 to both sides to get y equals 2. So we have obtained the point 1, 2. Let's find one additional point. Now let's let x equal 2. When x is 2, we have y minus 2 times 2 equals 0, which is y minus 4 equals 0. And when we add 4 to both sides, we get y equals 4. And thus we have the point 2, 4. Now we can graph this equation by plotting the points and connecting them with a straight line. To do that, let's first note that we're going to let our dotted lines represent 1 unit on both the x and y axes. So the max on both our x and y axis will be 6, and the minimum will be negative 6. Now we'll plot our points. Both the x and y intercepts are at the origin, so we plot a point at 0, 0. We also have the point 1, 2, so from the origin we move right 1 unit and up 2 units. And we have the point 2, 4, so from the origin we move right 2 units and up 4 units. Now we connect these 3 points with a straight line, drawing arrows on the end in order to graph the equation.